Welcome to the ChemDoctor, and this is the first presentation in a series that I'm going to produce on ions. Now, ions are a very important concept in high school chemistry and university level general chemistry because of the sheer volume of inorganic chemistry that's addressed in these courses. And yet I find that this concept is gravely misunderstood by most students, most beginning students from the outset of the course. So what I want to do here is produce a series of presentations that are going to lay out this concept from the most simplest aspects of it into the more complex ones. So let's start at the beginning. And on my screen I provide you with a number of different informational aspects that we're going to need for this presentation. The first thing is to address basically the definition of an ion. So an ion is any kind of charged particle that results because of the imbalance in the number of protons and electrons that you find in the particle. Now we're going to start by describing this relative to the formation of ions from two specific elements, because this is the simplest place to start, where you have two atoms that are going to combine in a chemical reaction where you have the exchange of electrons. So first off, let me remind you that in any given atom you've got basically three kinds of subatomic particles. You've got the protons and the neutrons, which are responsible for over 99% of the mass of the atom. The protons carry what we call a charge, a positive charge. The neutrons do not carry a charge, which is the reason I'm using 0 here. All right, and then we have the electrons, which are on the surface of the atom, which we designate as having a negative charge. Now I've produced some other video presentations on atoms, and what you need to remember is that the designation of positive and the designation of negative do not have physical meanings. This simply means that the proton has an attraction for electrons, and the electron has an attraction for the proton. The positive and the negative is a way of designating that this attraction is mutual and is the same in magnitude. But oftentimes what we'll say is that same in magnitude but opposite in charge. And what we mean by opposite in charge is that these two particles have an attraction for one another. So if you place them within close proximity of one another, then the two particles are going to draw together, and they will remain at a certain distance from one another in order to form a balanced relationship between their mutual attraction, where the two particles will have their lowest potential energy when they form some level of distance between the two particles, depending on what the situation is. So this is a balancing act between two particles that have a mutual attraction for one another. In the lower right hand corner of the screen, what I've done is provided a little bit of information off the periodic table. Remember that the metals, which represent the vast majority of elements on the periodic table, generally undergo reactions with nonmetals, which are on the right-hand side of the periodic table. The reaction that metals usually undergo with nonmetals is the exchange of electrons, where electrons are given up by metals usually, or transferred from the metal to the nonmetal. All right, so let's see what happens when we have an exchange that occurs like this, where a metal atom gives up electrons to a nonmetal atom. So for this example, we're going to look at lithium and fluorine, and we're going to allow a chemical reaction to happen between these two atoms. So first off, let's deal with lithium. All right, now lithium has an atomic number of 3. That means it's got 3 protons in its nucleus. So I'm going to represent those protons this way. For this presentation, I'm going to ignore the neutrons because they're not involved in this transfer. They're not involved in the formation of the ion, and all it does is complicate matters by me putting them in here. So I'm not saying that they don't exist, but what I'm saying is that we're just going to leave them out of the presentation. So this little schematic right here would represent the nucleus of a lithium atom I've got all 3 of my protons in here. And then we're basically going to have 2 electron clouds in the lithium atom. And in the electron cloud that's closest to the nucleus, we're going to have 2 electrons here, which I'm going to put in this way, designate this way. Okay, and then in the outer shell, we're going to have the 3rd electron, which I'll use a different color. This electron, which is red, is on the surface of the lithium atom. Surface of the lithium atom. Let me get that in here better. I misspelled this. Okay, there we go. Surface of the lithium atom. So this is the surface where we have a single electron. For fluorine, on the other hand, okay, its atomic number is 9. And that means that if we looked in the nucleus, you're going to find a total of 9 protons in here. So let me just get these guys. You need to remember as a student of chemistry, let me see how many I've got here. 3, 4, 5, 6, 7, 8. So here's my 9th one. The protons are fixed. In other words, the protons, remember the definition of an atomic number is the number of protons, because the number of protons designates the identity of an element. So in a chemical reaction, the protons are never changing for a particular atom. It's the superficial or the surface electrons that are undergoing changes, and they can be exchanged between atoms. Now, on the inner electron shell, like with the lithium, we're going to have a total of 2 electrons. So I'm going to go ahead and put those in like this. All right, and then we're going to have an outer shell for the fluorine, an outer electron cloud that's going to have the remaining electrons. Since we've already used 2 of them up on the inner shell, that means that we're going to need 7 of them in this outer shell out here. All right, and so let me go ahead and put those in. All right, so let's see, we should just let me make sure I have a total of 9 here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 total electrons. So if we take a lithium atom and we put it in close proximity with a fluorine atom, there can be a chemical reaction. And if a chemical reaction occurs between the lithium and the fluorine, an electron is going to be transferred from the lithium atom, which is the metal, to the outer shell of the fluorine, where in the fluorine we're going to end up with a total of 8 electrons in the outer electron cloud. Now, I cannot in this presentation get into this magic number of 8, except to say that I have produced a number of videos that talk about electron configuration. So I don't want to be distracted by that issue right now, except to say that especially period 2 atoms tend to have a total of 8 electrons in their outer electron cloud after they've undergone a chemical reaction. So in this case, when we combine a lithium metal atom with a fluorine nonmetal atom, generally speaking, there can be a chemical reaction where the lithium will transfer a single outer shell electron into the outer shell of a fluorine. And when this happens, you're going to end up with a new situation where these 2 atoms now, both of them, will have an imbalance of protons by comparison to electrons. So let's take a look and see what happens with the lithium first. All right, so what I'm going to do is use an atomic symbol here to figure this out. So we have our lithium. It has its atomic number of 3. So it's going to have a total of plus 3 protons, because each proton is worth plus 1. It has now given up one electron to the fluorine though. So it only has 2 electrons. Now when we do the simple addition here, you can see that it ends up with a charge or 1 additional proton. We haven't added a proton here. What I mean to say is that we have basically neutralized 2 of the protonic charges in the nucleus because we still have these 2 electrons, the electron here and the electron here, which were on the inner shell. That leaves 1 proton now, which is a charge of +1 beyond the amount of electrons that are available to neutralize that charge. So we say that the lithium now has been ionized because it has 1 extra proton by comparison to the number of electrons that it has left in its outer shell structure. So we designate that fact by using this sign, which I'm going to emphasize with a different color. So we say that it is now lithium +1. All right, and we don't write the 1 in here, we just use a plus sign. The fluorine, on the other hand, okay, which has an atomic number of 9, has still within its nucleus, that's not going to change, 9 protons. But now, look what's happened because of the transfer of that electron. And I'm going to go ahead and write it in here using a different color. We'll make this one sort of green, right? Coming in from the lithium. So the lithium electron, all right, which is now transferred. How many total electrons do we now have in this atom? So counting up, we've got 2 here, 1, 2, and then 3, 4, 5, 6, 7, 8, 9. Now, by the addition of this guy, we have a total of 10. So I'm going to write that in here, 10 electrons in this situation after the chemical reaction. So when you add the number of electrons to the number of protons now, you can see that we have a net additional charge of 1 electron. So now this atom has what we call a net charge on it. And we would write it this way. We would write this as F with a negative superscript like this to indicate that it has 1 extra electron. So now you see the unique situation here is that we have produced 2 atoms that have an imbalance of electrons versus protons. In the case of the fluorine, it has an extra electron. In the case of the lithium, it has lost an electron, so it now has within its structure an additional proton. This results in a mutual attraction between the lithium ion, we call this lithium ion now, and the fluoride ion. So we go from calling this fluorine to fluoride. Fluoride, and this is now lithium ion. Lithium ion. All right, and these 2 things, coming back up to the top of my screen here, the lithium ion and the fluoride ion act the same as my original description here. You have a particle that has a positive charge on it, and you have a particle that has a negative charge on it. So these 2 guys have what we call mutual attraction. All right, and they form what we call a salt. So we could write this way. It's a salt. And the salt has a positive charged cation mated up with a negative charged anion. All right, so the fluoride is what we call an anion. It's a negatively charged particle. And the lithium ion is what we call a cation, a positively charged particle. positively charged particle for the cation, negatively charged particle for the anion. And with that, I'm going to go ahead and close this presentation.